the traditional approach that we've been taking to M&V, whether it's deemed, so deemed is based on a work paper from 3 years ago. We're in a new normal, not really relevant anymore. Traditional like energy modeling. Well, what assumptions are you going to use? A building is now being operated and behaving totally different than it did last year, right? And it's changing. Potentially, it was ramping back up again until this week, and now it's ramping back down again. How do you manage all of those adjustments? And then the type of M&V that we've been doing in the CalTrack methods, which is IPMVP option C, where you're using past energy consumption. We generate a statistical model that explains how the building reacts to weather and occupancy as a predictor of future baselines in consumption, which in general is very, especially at a portfolio level, accurate. Not anymore, not by itself. And this is really, as an example, kind of an extreme case on the commercial side, why? So looking across different sectors, and these are NACE codes, we've rolled them up into categories because there's so many of them. You can see that the difference between like a fitness center or a beauty salon going into stay-at-home orders versus a grocery store or a bank is profound, right? A bunch of these industries were just completely shut down while others are still operating. And if you look in the distribution to the left, which is a general distribution, we find that there are these different distributions for each and every one of these categories, where you have grocery stores that now are they're open at 6 in the morning instead of 8 because they want to have special hours for at-risk people to use it, et cetera. We just know that there are categories of customers that have increasing energy costs. And then a whole bunch of other customers that are potentially almost entirely closed or at a very, very minimal level. So when you combine the fact that there's all these difference by sectors, difference by customers within the sectors, and then a difference in recovery rate across these buildings also, it's a complicated problem. And that's the problem we set out to solve. Because without it, we can't measure. And while measuring sounds like an administrative cost, if you can't measure, you've probably heard the adage, right? You can't manage what you can't measure, right? And that's the problem. That's why we need to be able to account for this stuff properly, or we're going to end up doing the wrong stuff. Might even think we're doing the right stuff, but it might be that we're just selecting for certain customers, for example. So go ahead and go to the next slide, Carmen. And I just want to talk a little bit before I get into like what we're doing here. These methods that we're going to describe, which are actually built on about 3 years of work that we've been doing on automating of comparison groups with different levels of success. And because the comparison groups are not just for COVID, there's a lot of effects. Changes in the economy can affect energy use. You can be measured, you can think you're saving energy, but really what you're saving is people, business is not as busy as it used to be, et cetera. But the other big profound change that we have to think about across the board in California in particular, but really nationwide, is decarbonization of the electrical sector in general, electrification of transportation, and electrification of buildings. Right on the heels of COVID, these are profound changes to how people use energy, which similarly renders these traditional unadjusted methods of M&V kind of obsolete, right? Without it being able to account for this stuff. What happens when someone puts a car into their house? What happens when they put a heat pump or a heat pump water heater in? And how does that affect baseline, and how do you measure it? It becomes a real challenge. So go to the next slide. I'm not going to explain the details here. I'm going to let Carmen do that with some fancy slides. And this actually builds if you want to hit the next click. So I'm going to tell a story because I didn't invent any of this stuff. I'm just taking credit for it, and I can barely explain it. McGee Young, our CTO, and our team, Carmen was on that team of a data scientist that were working on this project. Adam Shearer, Mariano, great, really smart folks. And we came into this thinking like, we're going to apply some of these methods we developed with the Energy Trust of Oregon and other markets for sampling and creating comparison groups, and nothing worked. That was what we figured out. We tried really simple approaches. Can we come up with adjustments by sector by zip code? And we kept finding massive errors because there was so many there's so many biases happening. We tried really complicated approach. Can we create comparison groups for each individual customer? Similarly, all sorts of biases. I was getting worried as CEO, saying like, crikes, can we actually do this? Wasn't that clear. So McGee Young, who's our CTO, who we give a lot of, we constantly kind of make fun of him for being a PhD in political science. He was a professor, and how kind of not relevant that seemingly is. But he was on a bike ride and he had this realization. He goes, wait a minute. This is like a political poll, except we know who's going to vote because we have treated customers. And when you do a political poll, you do something called stratification of the sample, right? You don't just call everybody up and say, who are you going to vote for? But you guess at the composition of voters and you say, well, 60-year-olds vote, 80% of the time, 20-year-old votes don't tend to vote, 22% of the time, and you stratify your sample to reflect who's going to vote. And we have this advantage that we know who's going to vote because we have treated customers we're trying to match. And so the methods that we're going to describe that we developed with GRIDmeter, which are really innovative. Now, the idea of stratified sampling by itself is not like a new art exactly. But this is going to sound like 4-dimensional chess, but it's really 5-dimensional stratified sampling. So we beat 4D chess. Is an automated approach where we can actually go through a search to create a binning method that develops the stratification schemes, that tests all of the existing parameters that we have to identify the best match parameters. And what we're actually doing, and I'm going to steal all of Carmen's thunder, is not just coming up with an average in terms of a comparison group, but we're creating a comparison group that is actually reflective of the participants across the entire range of the distribution. From the lowest level of use to the highest level of use, we're matching the entire distribution, and that rolls up to the average, which is a very different thing. And it's turning out to be exceptionally predictive. And the level of precision we're getting when we're able to test these comparison groups is so surprising that when we got our first results back using this method, which took a lot to implement, our first instinct was we were doing something wrong because we couldn't really tell the difference between the comparison pool and the treated pool we were trying to match, which is pretty darn close. So a couple quick slides and I'll hand it over. A little more like housekeeping. Grid.recurve.com. All of these methods, access to the code is all there. So feel free to go there and research away and dig in. We're trying to be as transparent as possible. Next slide. And not only are all of our machinations and discovery and discussions in GitHub and available for review and to build upon, but we also have open sourced all of that work. And so, we're implementing this at scale with multiple utilities. We run that on our platform, but the code that we're running is the open source code that is actually available for everybody without any restrictions. Part of that was, that's why DOE funds it. But the other part of it is that we really do think these tools need to be out there. And as we do this sort of math, one of our first principles is transparency and reproducibility. So, you need to make these adjustments to get an accurate calculation to claim savings or make a payment to an aggregator or a customer. And so we need to make sure that the math that we're doing is transparent and reproducible by all parties. And so that includes privacy protecting the data, which is, pay attention tomorrow, there's going to be something called energy differential privacy released publicly, which is a bunch of code libraries that we're using to differentially privatize the data, combined with this GRIDmeter and the Caltrack methods to get to these outcomes so that there's no black box, right? You can actually understand why we're doing everything the way we're doing, but also see precisely how it's being implemented so that it's reproducible to all parties and available.